Hello and welcome. In this video, we are going to focus on our current P6 modified. This version of the P6 modified focuses on basic inventory management system. You could think of this as a little kiosk or a little store inventory system where we can store the contents of the inventory in a CSV file, and we simply work to import it into an array of structures, ultimately using dynamic memory allocation, searching the array of structures. Later on, we'll worry about adding things to the array of structures, but then exporting some results. Now, this video is part of a larger series of videos that focuses not only on the original P6 that handled static memory allocation. In other words, basically, we were declaring arrays in our main and then passing them to functions. But in this video, with our P6 modified, we are focusing then on using malloc and specifically realloc to allow for us to control our memory footprint. Now, I've handled a lot of this in earlier videos. If anything, I've done this particular series a little differently in that I've done virtually no testing other than the import products function in an earlier video. So you could argue that I've been somewhat of a bad developer, and that's a fair criticism. Ideally, what you would do is you would test each of your functions in isolation to make sure that they work, and then you would worry about integration testing. Now, I decided to do this one a little bit differently because I want to show you some of the problems associated with basically writing, in this case, let's see, how many lines of code do we have? And we still haven't even finished it. If you ignore that last function that I'm going to handle later on, I'm already at about 547 lines of code. And of course, there's extra line breaks and things like that in there. So still a fairly large application, given the fact that I've done virtually no testing. Now, what I have done is I have brought over my main from my original P6. So the instructions for P6 and P6 modified are the same. From the user's perspective, nothing has really changed. I do want to talk real quick about the purpose of each of the functions, including some of the convenience functions, so you can understand then how we're going to go about testing them as we integrate them. And so to begin with, we have our original import products function that basically just reads in the file name, stores the results in an import results. Basically, each row gets converted into a structure, and then that structure gets dynamically added to our import results. Essentially, what we're doing is we're growing the array as we successfully read in lines from the CSV file. Now, the second function of interest to us is going to be the display product, which simply displays one individual structure. And then we have this display products, plural, that will allow for us to loop through each of the products that we have imported, and essentially one by one, it sends it to the display product. It's controlled by N, meaning that that tells you how many products we ultimately have in our sources. And effectively what it does is it drives the display product function. Notice the difference in plural and singular. The same scenario plays out with the copy products, although there's a little more going on there. The copy product accepts an address of a source structure, which note can't be changed, and the destination, which again is assumed to be pre-allocated, but the individual fields in the destination can then be updated based on the source. Now, again, we're not doing much validation of any of the fields. If anything, we could argue that that should have been done, and we can leave that for later videos. We're going to assume that whatever is in the source is, in fact, a good structure. In other words, all the fields are valid, and we're just copying them over. The copy products does the same thing, or very similar to what the display products does, in that it drives the copy product function and essentially loops through all of the sources. However, though, we are very specific about which of the sources get copied over. And that's the need then for the indices array. The indices array simply tells us which elements out of the sources we wish to copy to the destinations. And since we don't know necessarily up front whether or not we have a valid indices to copy over, we grow the destinations after we verify that the indices or the index of a given source is in fact valid. To give you a quick scenario of where that could be a problem, for instance, if you passed a negative value for an index to sources, you would end up crashing your application. Likewise, if you extended or went beyond the allocated memory for the sources, again, you could have a potential crash. And then lastly, we wish to export then an array. In this case, we call it our exports results. We can test this both with and without search. And to get an idea of what some of the searches would be, if you search by double, you basically are searching through each of the structures, looking at a field name, in other words, making sure that it is a valid field in the structure. And then we look for the min and max value. And if it passes that condition, in other words, if it falls between the min and the max, then we simply add it to our indices array. Again, note here that the indices is being passed by address. So in other words, basically we can grow the indices array as we need in the search function, as well as passing the count of the number of valid indices also by reference, which means that we can keep track of how many elements are in the indices. Now, again, that's a lot of thrown at you in one video. If that doesn't make sense for you, then what you need to do is you need to go back to the videos that focus on the individual functions, and I explain a little more about what each of the functions do. If anything, we are going to be bad developers in this particular video. And if anything, hopefully I have some mistakes. It would actually be unfortunate if I don't have any mistakes, because I really want to show you a combination of things. Number one, I want to show you how to actually implement all these functions. But number two, I want to show you the downside of writing all of this code without testing it. And that is that a lot of integration problems can come up. And so I'm going to pick up with where I left off in my main from one of the first videos. You'll recall that I copied over all of the structure for my if statements from my P6. Basically, what I'm doing is I'm doing my switch triaging, my search and search ID, search name, search type, description, which I am not currently handling, will handle in a later set of videos, and the price and the quantity. And if you want a quick reminder of how this plays out real quick, we can just go ahead and CD into our P6 modified, in this case, our practice version of it, dist debug min-gw. And you'll notice a couple of things here. Number one, I have my products.csv. If we want a quick reminder of what that file looks like, we're just going to open Explorer real quick. And I'm going to, not really sure what just happened there. I think I grabbed the wrong window. Let's try this one more time here. Grab the correct window this time. And you can see here now what my CSV file looks like. And the idea is I'm going to use this as my inventory. And then before we go too much further into that, I just simply want to test my P6 modified switches. The first one, of course, being that you pass no switches, in which case you get the help, which I probably should go back and update now that I'm closer to finishing the application. We can also pass the search by itself. And again, since I don't have enough arguments, I should get the help. And then we do the search ID. And again, because I didn't specify an ID, it just simply pulls up the help. And now I am going to go ahead and specify one of the IDs from the file. And so in this case, I'm going to do ID 001. And you can see that I do have some output. And again, just a quick reminder of why I have some output, including the n is equal to 10, is if you go back to now the code, you'll see that I have run my import products, which is the only function that we have really so far tested. And I'm passing to it the array, or what ultimately will be the address of the array of the structures. Now, keep in mind here, if we recall from the earlier video, I'm actually passing a null value for my import results. And what is actually happening is the function itself is allocating, or reallocating, however you want to think of it, the appropriate amount of memory to store 10 structures. And why do I know it's 10? Well, it turns out that I can either count the number of rows in the file, or I can simply come over to the console and you'll see that n is equal to 10 after running the import function. And again, that's the purpose of this little print statement. We'll be using a number of these as we go along to sort of track the evolution, if you would, of our arrays, as well as the values associated with them. And then what I do is I just simply have a little for loop. You can call this somewhat of a sanity check, where I'm just proving to myself that I am in fact getting my IDs. Now, this is where we want to start testing the other functions. And specifically, the other functions that I wish to test to start with is going to be my display products, the plural version of it. Now, if you aren't familiar with how this one works, you should go back to the video and look at how I set it up. Remember that the display products, again, the plural version with the S, simply drives the display product, or the singular version of that function, that will ultimately display an individual structure. So let's go ahead and get started. Let's go ahead and turn off this noise, if you would. In other words, we don't need this, and ultimately we may actually decide to go ahead and delete it in its entirety. I am against deleting code until it's absolutely time to clean up, because if you delete code, you may intentionally, or rather unintentionally, repeat mistakes. And so until you are ready to truly release your application, I encourage you just to simply comment it out. But what we're going to do is we are going to leverage our import products, and we are going to leverage the fact that our import products will return either exit success or exit failure. And what we want to do is we want to check to see if our import products returns exit success. Well, at this point, then what we'd like to do is simply display whatever products we imported. And what we can do is we can simply call our display products. And again, what we'll do is we'll pass to it our import results, and we specify how many we expect to be in there. Now, again, you can see the benefit of this print statement. This will tell you that n is in fact equal to 10. You could argue that we could leave that in there, but again, we can see that we will generate quite a bit of noise on the command line, and ultimately we just decide how much noise we wish to generate. So we can go ahead and build it, and again, since I haven't made any changes in which switch will operate, if I run this now, you should see that I am getting a nice little table for each one of my items in my products.csv. My 1 is a Coca-Cola, 2 Sprite, 3 Pepsi, and so on. If you've been following along with the P6 version, the original version of this with static memory allocation, then you should probably recognize most of the items in this inventory. Now, let's go ahead and take this a step further. Now that we know that we've successfully displayed the products, we can either leverage the exit success here, or what we can do is we could simply leave this one alone and count on the fact that since we have been able to successfully import, then what we can do is move on to the next step. So I'm going to put a little comment in here that says leverage the exit success optionally. But what we can do now is we can now get to the heart of the application. And that is the idea being that we would like to check based on the ID, or search based on the ID, the import results. And again, since the ID in this particular example is a character vector or a string specifically, then what we would do is we would use our search function, our search structs by string exact. Again, probably a terrible name for a function, but again, since this is meant to be very explicit and almost self-documenting here, I think it's pretty clear about what this function does. It's going to search our import results. It's going to look at a specific field. Now, optionally, you could pass this directly from the argv square brackets 2, or you can simply type this in and strip off the slash. There's a couple of options for how you could pass this. I'm just going to type this in because there is such a close correlation between the field I'm looking at and the switch, and the exact match that I am looking for. And in this case, that is going to come from my argv square brackets 3. In other words, if you go back to the original documentation for the project, you'll know that that is the argument that comes after the slash ID switch. The other input arguments are going to be the indices, or rather the array that is going to hold the indices. I'm going to go ahead and put this in now, and specifically I'm going to put it in as an address of the indices. We have not yet created this variable. We'll do that in just a second. And we want to specify both the n for the number of elements in our import results, but also then again the address of our m, which will keep track of the number of matches or the number of indices in our indices array. Now again, remember that this is going to be dynamic memory allocation, so this is going to be a little bit different in that we are going to pass the address of a variable that holds the address of the array, therefore allowing for us to update that address in the function. So how do we do this? Well, it turns out it's very similar to how we allocated the memory for our import results. And specifically, if you'll recall that we did a product properties pointer. In other words, we're pointing to an array of product properties. Well, we can do the same thing now with an integer. We can simply have an integer pointer, and we will again just simply call this indices because it seems like a good variable name. And before we forget, let's go ahead and add our m, which is going to simply keep track of the size of our indices. And then much like we initialized our import results, we're going to do the same thing now with our indices, and we are going to initialize it using an int pointer, and we're going to simply set it equal to null. And again, this is arguably sometimes not necessary, but I like to encourage the initialization of all of your variables to a known value, including your integers, much like your m and your n. But depending on how you are allocating and reallocating and reusing your memory, this may or may not be necessary. In other words, basically, this is going to be application specific. For this particular example, as somewhat of a, you could argue, safety mechanism, and to fall in line with the logic that we've been using, we will in fact initialize all of our pointers to null, depending on what data type they are. So at this point, then we should have all of our warnings or all of our errors go away. We're going to go ahead and build it to see if we have any syntax issues. And again, it seems to pass a compile. However, that absolutely does not mean that we are going to be successful. And the easiest thing for us to check when it comes to our search structs by string, again, I've done absolutely no testing of this function, so I have no idea if this is going to work, is to simply display, much like we did the n earlier here, we want to display the value of m. And again, remember that that's going to be updated inside of the function. So I'm going to use roughly the same approach that I did when displaying the n, and then I'm simply going to display whatever the value is. Sorry, I was talking and not typing there, my printf of the m value. I think you could probably get a little laugh out of this because I've been using MATLAB quite a bit as well. So bouncing between languages always causes some interesting little problems like this. Again, we've successfully compiled, and now I'm going to run my switches again, and you'll see that I have in fact found a value. How do I know that? Well, my m is now equal to 1, meaning that I think that I matched something. And again, I'm being very careful with how I word this because we don't technically know what I matched. We just know that my m is equal to 1. And we can continue to test this by putting in an ID that I know doesn't exist. And you can see that I get an m equal to 0. So it looks promising. We're going to go back to that first example where I have my ID equal to ID 001. And if you scroll through this a little bit, you'll notice that it should theoretically be a Coca-Cola. However, how can we check this? Well, what I can do is I can simply loop through each of the matches to look at the indices that were in fact matched. And so what we can do is a similar trick to what we did with the n when we were checking to see what we had imported, in that what I will do is I will again leverage my index variable going from 0, index less than m, and then index plus plus. Except this time around, what I will do is I will simply try to print out the index of the match. In other words, basically what I want to do is I want to see where did I in fact find the match. And so the way I do this is I do indices square brackets, and then %d, because I wish to show what index I'm looking at, as well as the value in the import product. So we're going to have two things that we're going to display here. The first of which is just going to be the index itself, and the second one will be the value stored in the indices array at that location. Now, I'm going to go ahead and build this and run this, assuming that I don't have any mistakes. And I come back out here to the command line and I rerun this, and you'll see that my indices 0 is equal to 0. Well, that probably seems a little strange until we change this to perhaps another value. Let's pick ID 003, which I know exists, and you'll see then that it should be the index equal to 2 in the import results. And sure enough, if you come up here and you look through, if this element right here represents the 0th value or the 0th index, however you want to think of it, and this is the index equal to 1, well, sure enough, this is index equal to 2. You can also think of it as the row in the CSV file, of course, shifted by 1, because if you recall in C, it's 0-based indexing, whereas our row count is 1-based indexing. So getting back now to testing, I would encourage you to consider leaving this in, perhaps at least until you make sure that you really and truly understand what our search structs by string exact is actually doing for us. But I'm going to go ahead and comment this out just for the purposes of reducing the noise on the command line. And again, I'm going to play the same trick, or roughly the same trick that I did with my exit success from earlier, in that I'm going to simply check to see if my search results are equal to exit success. And in that case, I simply want to move on to the next step. The next step, of course, being that I wish to copy whatever I found in my import results now to another array. And I think you can guess where we're going with this based on the names of our functions. I would like to ultimately then export them, assuming that I am successful with my copy products. Well, what we want to do to accommodate for that is we simply create now a second array pointer, again, of the same type as my import results. I am going to simply call this my export results. And the idea then is the same with the initialization. As a matter of fact, you can go ahead and do a little bit of copying and pasting here, in that now my export results points to a null value. And so at this point, what we can do is we can come down, and then inside of our if statement, we simply make a call now to our copy products, again, plural, because the idea is that the copy products behaves very similar to the display products, in that it will simply loop through each of the products that we wish to copy. And how are we controlling that? Well, it turns out that was the purpose of our indices. In other words, we would keep track of the index that matches. And in this case, we only had 1 or 0, but we will see in a later example that we could have multiple values. And the idea there is that we would copy all of them over to our new array. Well, what we can do is we could simply then pass to this function our import results. We can also pass to this function then the address of our export results. We want to pass to it the indices, but notice this time around, I can just simply pass the indices themselves. I do not have to worry about passing it by address, because we do not intend for the copy products to change anything about the indices. We are going to pass the n, which is going to control the number of elements, or at least recognize the number of elements in our import results. And then we still pass the address of m. Now, I discussed why we need to pass the address of m in the video that focuses on the copy products. There is a couple of ways that we can handle this, but effectively what this does is this allows for us to control the copy products results, in other words, the export results, so that we know exactly how many elements were actually copied over using our copy products. Now, again, I have not tested any of this, so this may be a source of an error. We will see. So far, we have a successful compile. And what we'll do is then we will attempt to see if we can copy over a results. And again, we don't have any crash or anything like that, but I have no noise. And so what we would like to do is we'd like to create some additional noise on the command line, arguably more than simply our display results or display products. What we can do is we can actually leverage the same function with a little bit of tweaking here. What I'm going to do is I'm going to put a print statement in front of the display products, and I'm simply going to acknowledge that this is our import results followed by a new line. And I'm going to repeat the same process now after my copy products, and that I am going to display then using the display products. But the difference being is I'm now going to use my export results, not my import results, and I'm going to keep track of the number of things that I've actually copied over using my M variable. And again, we're going to go ahead and build this. And if we don't have any mistakes, again, what we can do is we can come over here to the command line. We can run this, and you can see that I now have potentially, or rather I have successfully moved. I have a little typo here. Let's fix this real quick before I explain this. Got a little too carried away with my copying and pasting. This is now, of course, my export results. Let's build this one more time, and then I'll explain it. If we run this again, you'll see that my import results resulted in 10 rows and 10 elements in my import results structure. And I found the one thing that matched my ID. And you can see here now I have my export results, which is another array. And I have successfully copied over that particular product into that second array. So far, this looks really promising. And I would actually make a pretty strong argument that you should probably leave this particular line of code in your application all the way up to your delivery to the customer. Why? Well, because this is a nice amount of noise. In other words, it tells the user that you did, in fact, find a match by simply displaying the products that matched. And at this point, the last step is only to export those results. And again, what we can do here is we can simply set up our if statement as such that if our copy products was in fact successful, in other words, that our copy products is equal to exit success, well, we'll need to be careful about where the brackets go, and we probably want to go ahead and push this code inside of the true branch of this if statement. But then inside of the successful copy products, we can simply then make a call to our export results, and we simply pass to our export results the export products, rather, sorry about that. Our export products, we pass to it the file name. In this case, we're just going to call it results.csv. We are going to pass to it the export results variable and also the M. Keep in mind, the M just tells the function how many results it's looking through, because remember, with the dynamic memory allocation, this export results array could be 0 elements. It could be 1 element. It could be 1,000 results. Again, it just depends on how many matches you have. At this point, let's go ahead and build this. Again, we hopefully will have no mistakes. And then we can come out here to the console and we will run this with the same switches. And this time around, when I do a dir, you'll see that I also have a results.csv. And if I go back to the folder that had my products.csv and I simply drag and drop into NetBeans my results.csv. You'll see that I have, in fact, found, if you would, my ID 003, or in this particular case, it's a can of Pepsi. Now, to prove that this wasn't just a fluke, let's go through here and let's change this maybe to ID 005. And sure enough, I find the Oreos. And if I do ID 000, in other words, I didn't have any valid return values. In this case, then I am not overwriting my CSV file. And again, you can decide how you want to go about doing this. I will probably go back and change this code in a little bit of an addendum. We could do it right now. If we could find this real quick. The idea here is, if I do end up with 0 values, do I overwrite the CSV file? So let's go take a look real quick in our export. How did we handle this? And so we check to see if our n was less than 0. It is not, in fact, less than 0. Let's see if we can figure out. I think it's our copy function that is probably a little bit too aggressive here. Let's see if that is the case. No, n less than 0. Here we go. Okay, so we mentioned this in the copy products video, but I actually did forget to take it out. It turns out we do not have to validate the indices, because it is okay for the indices to be null, because effectively what we're going to do is we're going to be checking the n. So in this particular case, if n is equal to 0, we probably need to have another check. If indices, yes, here's how we can handle this one particular case here. If n is less than 0, could cause a problem. If n, however, is equal to 0 and our indices are equal to null, so in other words, the scenario here where if n is greater than 0 and indices are equal to null, that is really the scenario that we want to avoid. It means that somehow an n was passed that was expecting to have values, but there was, in fact, no address or no memory allocated for the array. Again, nice little bug that we found here. It's an edge case. It's something that we want to test. And now when we run our ID 000, we're still getting a warning here. Let's see if we can figure out where this is from. So n greater than 0, and, not or, build. And we run this real quick, and we're still triggering this. Let's see if we can figure out real quick what's going on here. So our indices, the only time we should be triggering this is if n is greater than 0 and indices equal to null. And this is in our copy products here. Actually, hold on just a second here. I think I've actually done this wrong. I'm actually looking at the wrong function here. So actually, let's do a revert here. Let's undo a number of times. I'm going to take a step back here. I feel like I am looking at the wrong location here. So let's undo this all the way back to here. All right, and let's see that we have our original bug. Please provide valid indices. And again, we should see real quick where we are getting this from. There's our export. All right, so I'm not immediately seeing where the problem is. So again, I'm going to keep recording here because this is part of the integration testing that we wish to do. Let's see if I can figure out where I'm actually getting this message from. I'm just simply going to copy and paste it in here. All right, so our copy. All right, so our copy resulted in our copy products is not the problem in this particular case necessarily. If our n is equal to 0, we should again be fine. So really it's the scenario that we wish to check is if our, let's rewrite this real quick, if our n is greater than or equal to 0 and our indices equal to null, then please provide valid indices. And my question then becomes, did we in fact, so with the copy product, actually, it's not my n I need to be checking, it's actually my m. There's the problem. Okay, so I need to check to see that my m, in other words, that I'm not in fact expecting to have indices, and then I got tripped up with my variables here. So my m corresponds to the size of my indices. And then if we run this, then well, we're still getting a 0. So let's see if we can figure out what the problem is here. So in this case, now that we actually have the right variable, we actually need to drop our equal sign. So we're only interested in the scenario where m is greater than 0 and our indices are equal to null. Again, we kind of went full circle there in our argument. If I had picked up on the right variable, we wouldn't have had this problem. And now what we have here is error, please provide valid sources. In this particular case, then our copy product, the sources are triggering us. So please provide valid sources. And why are we triggering this now? All right, so what we want to do is we want to go back into our main real quick. We could do this a couple of different ways. We might as well go ahead and debug this to figure out exactly where we are having a problem. So I'm going to right click on my P5 modified practice and go to properties, go to run. I want to set external terminal. I actually want to go through and put the same switches that I would from the command line. So I want to do a search. I want to search it based on, in this case, the ID. And I'm going to put in, first, I'm going to put in a invalid one because that's ultimately what we're trying to test. It appears that we have the valid one working. We just seem to have some of our error checking wrong. I'm going to go ahead and hit apply. And then we want to make sure that we have selected external terminal. And then because we're dealing with files, we're going to have to do one additional step here. We're actually going to copy our products.csv into the root of the project folder. Again, we can control this a couple of ways, but fundamentally, this is the way that NetBeans does debugging, is it looks for files by default in the source of the project folder. And now what we want to do is we want to start down the debug path. And what we can do is we can go up to our main and essentially put a breakpoint now on the branch that we're wishing to troubleshoot. And we're pretty sure that the import results is working correctly. We know our display results is working correctly. We're just not sure what's going on down here with the search and anything below that. So let's go ahead and start debugging this rather than blindly guessing now and changing logic. And so we're going to step now into, you can see I have my console up here that's basically printing out everything that would otherwise be going to the console. We have our debug console now. And so I'm going to just simply step into my search structs. And we're going to see here my search structs. I can come down here to my expression evaluation. And just in case you don't have this, you can go up here to your Windows, to your debugging, to your expression evaluation. And what we can do is we can spot check some of these, starting with our search results. We can look to see I'm sorry, search structs. We can look at our search structs, and we can see that we have a value there for them. So in other words, we should expect to jump over that branch of the if statement. Likewise, the field name. I think all of this portion of it should be fine. The exact match, our n, if I recall correctly, should actually be equal to 10. We're going to initialize our m. Our indices are going to be equal to null. That's what we expected. And now what we want to do is we simply loop through. And since our particular value that we're looking for, so in this case, it's not our search index, but rather our exact match, should be ID 000, and we know that we're not going to find it, then what we can do here is we can actually speed this process up just a little bit by jumping all the way down here and putting a breakpoint on our results. And what we're going to do is we're just simply going to go ahead and continue. And what we want to do is we want to spot check some of these things. And I think my indices, and specifically what I want to do is I want to look to see what is it pointing to, and it is in fact null. So that's good because that's what we want. We know that's what we want because our m is also equal to 0. So that means that we have not found any matches. So again, this looks fine. I think we just have some logic in our copy products off. And so let's make sure that we have this right. Let's look to see what our sources are real quick. So if we look at the sources, we have that is actually has a value or an address associated with it. I can spot check one of this by going to the source is 0, and you can see that I'm actually getting the 0th element, which is fundamentally in our import results. So that part seems to be fine. So if I step here, that's good. My m should be 0, and it is in fact 0. And let's see what our indices are. Yes, our indices are in fact null. So in other words, our and condition should not be satisfied. And now that works correctly. Let's check our n. Our n is still 10. Is our m less than 0? No, the answer to that is no. We could probably reorder our validation a little bit at this point now that we've updated it. And then technically speaking, we have nothing to copy. And so unless we've made a mistake here in our logic, our m index should be, let's make sure that we didn't do anything silly here. Our m index is in fact 0. And 0 is in fact not less than 0. So our while loop should run 0 times. This will actually just be an affirmation in this case. And then we have our results, and we're now back into our main. At this point, we want to display our products. And I think I now see what's going on here. Yes, yes, yes. Okay, so this is again a nice opportunity here. We actually have some room for improvement. I'll probably make some notes on the other videos here, but you'll see that we didn't handle one scenario very gracefully here, and that is the scenario in which n is in fact equal to 0. I mentioned in the video, but because we're shifting from static memory declarations to dynamic memory allocations, we could technically have the scenario where the sources are in fact null. And so in this case, our sources are null. Why? Well, because we're displaying an array of structures that has no elements in it. So what we need to do is we need to improve our if statement ever so slightly. This one will technically work for a static memory allocation scenario. However, though, in this case, we want to do a compound condition where the first condition is that n is equal to 0, or for that matter, greater than or equal to 0. and our sources are null. In other words, somehow there was an imbalance or a mismatch between the logic needed for the n and the sources. And at this point, you could argue that you could almost reverse these two checks. Now, at this point, I'm going to go ahead and stop it because I believe we found our bug. Let's go ahead and build this. And really and truly, you could argue that the reason why this was a little harder to find was just simply because I used essentially the same prompt in two places. Please provide a valid source. And I also provided it in my copy products. So again, some places for improvement. And we can come along here and we can run this again. And again, we're still getting this. So let's see if we can figure out exactly where this is. We're going to debug one more time, but we're much, much closer now to figuring out where the problem is. I am going to simply go ahead and put a breakpoint here. I'm going to go ahead and debug one more time, and I'm going to turn off my other breakpoints, particularly here. I'm going to continue. Excuse me. I turn off that breakpoint and then continue. And I think now my problem, I think I've went one past here. So let's put our breakpoint here one more time. Debug it. And then we can step from this point. I'm not sure why I jumped over my last one here. So we're in my copy products now. And so I'm going to step, step, step. All right, so this all seems to work correctly. Let's go ahead and continue here. So my results, my M is still 0. I'm going to step. And now I'm going to go into my display here. And I'm going to step into it one more time. Let's make sure that our logic is right. So our N is equal to 0. And step once more, but our sources are equal to null. Currently the way we have this worded, we actually have a strict inequality here that we want to focus on. We do not want to include the scenario where N is equal to 0 because technically it won't matter. So let's go ahead and stop this one more time. If our N is greater than 0 and our sources is equal to null, that's really the scenario that we wish to handle. And now let's run this one more time. Now we have, please provide a valid export results. And now I think we've on to what's going on here. Basically, we need to cover this scenario also in our export. So let's take a quick look at our export function. And let's go through it here. Basically, the scenario that we need to make sure that we've handled is when our N is greater than 0, and meaning that we theoretically should have something to export, but we don't, and our export results are equal to null. And again, we kind of touched on this in the earlier videos. I just didn't pick up on this particular bug. Fundamentally, our for loop will control how many times we print to the file. But again, what this does is this allows for us to have a slightly different behavior than what we saw initially. And arguably what this is this is an improvement in our code, not so much a true bug, in that if we run this now with ID 000, effectively what this means is our results file is there, but it's empty. And so effectively, this is the equivalent of telling the user that they have no search results. So in other words, if you see an empty file, that means that nothing matched. So I'm going to actually walk back my earlier statement. This is actually not so much of a bug as in a change in behavior in the application. Now, because I did this live, I would be perfectly happy to admit if there was a true bug here. In other words, I only paused the video once, and that was more just to simply see if I could figure out if I had any more typos than to actually do any troubleshooting. I didn't do anything that you didn't see in this video. So this is truly a representation of the changes that I've made. But the second thing is, if you noticed initially, if I didn't have a match, I had the old results file. And you could argue that that would confuse the user. In other words, basically, if I ran my application the first time with, let's say, ID 005, well, I get a results. And if I come back and I ran it again with something that I knew didn't have any results, in other words, ID 000, but I still maintain the same results file, well, then you could argue that that probably isn't what the user was expecting. Instead, what you would get, or should get arguably, is an empty results file. Now, I could make the argument both ways. In this particular case, you'd actually have to reach out to your customer and figure out which one do they want. In other words, if you had a failed results search, do you still, in fact, want to keep the old results? So again, we could argue this both ways. I'm going to argue that rather than this being a bug, this was actually an improvement or a feature now, such that if we do, in fact, have no matching results, we simply get a results file that is effectively empty. So again, this was a long video. A couple of things that we covered in here was, number one, what a bad idea it is to just do all this code at once and then integrate it all at once. It takes quite a bit of luck. And if anything, we didn't have any true errors, which was arguably bad. The other thing to point out here is that I have not yet brought over my code to my other branches of my if statement. We could probably do this real quick. As a matter of fact, what I will do here is quickly re-implement this now with my name, leveraging the same process here, but I'm going to do it in more of an abbreviated fashion. Effectively, what I'm going to do is I'm still going to leverage all the same variables that we have. We're just going to go through it a little quicker now. I'm going to run my import. I'm going to run my import, not my import results. There we go, my import products. I'm going to use the same file, in other words, my products.csv. I'm going to go ahead and store it in my import results. And what I'm going to do a little differently here, still going to pass my N here, but I'm just going to immediately check to see if my results are equal to exit success. And then, unlike before where I use nested if statements, which are perfectly fine, and if anything, allow for a little more control and a little more granularity, I'm going to use a compound if statement, essentially the short circuiting operator, which means that I can do these one after another, and the first thing that fails will stop the process. And in this case, I'm going to go ahead and display my products, again, plural, and I simply pass to it the import results array, specifying however many elements are in that array. And again, I check to see if I have exit success. And if I have exit success, well, what I'm going to do is I'm simply going to move on to the next step, which is to search. And in this case, since I'm searching by name, we are still going to be doing the string exact. And again, what I'm going to do is I'm going to pass then my import results, but I'm going to also pass by address my export results, so that will, oops, not yet, sorry about that. I'm going to pass my import results. I'm not following along with my help here. I'm going to pass the field name, in which case then, since this is our name, not the ID, we're going to pass the field name as name. Again, we could leverage our argv square brackets 2 for that. And then my argv square brackets 3 will be for the field that I wish to do the exact match with, or the value I want to do the exact match with. I'm going to again pass my indices by address and my N by value and my M by address. And again, with this function, let me go ahead and give myself my maximum screen here. My exit success, or rather, I'm going to check to make sure that my function returned exit success. And in the event that I have successfully searched, then at this point, then what I want to do is I want to go ahead and continue then with the process. Now I wish to copy my products. This was the one that I accidentally tried to start earlier, in that I want to use the import results. I want to use the address of the export results to copy to. That essentially that's my source and my destination. And I want to use my indices as well as my N, and then lastly, the address of M, so that way I can control if there are any changes that need to be made in the size of the export results. Notice here the difference. The M here, the address to M, the results back here will tell me how many matches I have in my import results. The address of M here, or rather the value of M when the function returns, will be the number of actual copies into my export results. No matter what, we're going to check to see if that is equal to exit success. And then lastly, we want to export products using our export results. And we simply specify the M, which tells us how many actual copies were made into the export results. And again, we simply want to make sure that we have exit success. And if all 5 of those functions return exit success, well, that just simply means that everything went well for us. And we simply want to print a message to the user, note successful. And if not, then we had some sort of error. And I'm just going to put then error failed, and we can improve then on our messages later. And at this point, then let's go ahead and build it. Let's test this one out. Remember that now we're looking at the name field, not our ID. Again, we just need to see here. So we appear to have a mistake here. Oh yes, in my export products, I can't just export something blindly. I actually need to specify my results.csv. All right, so let's go ahead and build this. And we should now see successful. We can come out here to the command line. We'll look for the name. I'm going to start off with just putting something there. And so you could see here that we were successful. However, we didn't find anything. And so that means that we just need to go find something here. In this case, we're going to focus on the Coca-Cola. And if we come back and we rerun this now with a name that actually has a match in the file, well, hopefully we found the Coca-Cola. And we can continue on with this. Then we can use a couple of the other examples. How about our Jumex? And sure enough, we found our Jumex. And this just leads us with a couple more that we want to test. I'm going to leave some of these for you, particularly the numeric values. But what we can do is we can very carefully then copy this section over, and we can put this now under our type. The only change being that we change which field we are looking at. And so I think you can guess at this point, you can do some considerable amount of collapsing of your code because of the similarities, but we can go ahead and build this. And if we don't have any mistakes, we should now be able to test our type. Again, I'm going to start off with a type that is nonsense, just put something in there. And you can see that my results file is in fact empty again. This time around though, let's put something valid in here. In other words, I'm going to put in that it's a drink. And now you should see that I have multiple drinks, just to prove that it's not a fluke. I'm going to go ahead and put in fruit, and you can see that I now get all of my fruits. So again, I'm going to leave this video here. I think it's probably pretty trivial for you to move on to make the changes for your price and your quantity. I'm going to pause the video and I'm going to just complete these. I'm not going to go through them, but I'm going to show you that they do in fact work, so that way you can see how they should work. So give me just a second and we will be right back. All right, so welcome back. Hopefully you've been able to make the minor modifications that were needed now to make our search structs by double range work. Again, I have not tested any of this yet. Excuse me. I just want to show you the changes that you would have to do. First of all, you need to create variables that are type double for your min and max to ultimately be able to capture then the arguments from the command line. Keep in mind that you technically would want to check these to make sure they are actually valid min and max values. Don't just blindly accept A to F. There are ways to go about doing that. I'll show those in other videos. But again, to keep the time down, you'll see that really the changes that are made is I've switched my function signature to the search structs by double range. And all I need to do now here is I simply specify which fields I'm looking at. So in this case, I'm looking at the price. And for the other one, I'm going to be looking at the quantity. Now, the quantity is technically a integer, but there will be no harm in converting this over to a double for this particular example. Matter of fact, we handled that in our earlier video as well. And so at this point, we should be pretty much ready to test this. Again, it's one of the benefits of writing these applications this way, is that we can modularize this pretty quickly. As a matter of fact, I'm not even going to go ahead and cover the third option or the description field in this series yet, because I want to go back and talk a little bit about how to write our string find and how we would apply it. But at this point, then we should be ready then to look at our search. This time, what we're going to do is we're going to look at our price. And again, just to verify that this works, we should see the help pop up if we do not provide a min and a max. And so I'm going to go ahead and put in 0.5 and 1.5 for a min and a max. And if we don't have any problems, so we do have attempted to copy an invalid index. So that means that something is wrong in one of our functions. So it's good. Seems like we're going to still have a little bit of entertainment here in this video. I'm going to go here to our search structs by double range. Error failed to allocate memory is the only thing that I have here. Attempted to copy an invalid index. I think I've got something wrong in my copy function again. Let's see what we've got here. This is fair. There we go. Error attempted to copy an invalid index. All right, so let's take a look here. We are definitely getting invalid indices. Let's see if we can figure out what the problem is. That means that something is wrong in our search structs by double range. Let's see if we can find it real quick. Specifically, we're focusing on our price. So we have assigned then the value of the search index. And then we have incremented the search index. But for some reason, we are not getting those values passed or updated in our indices. All right, so let's see if we could take a look. We again look like we're going to have to do a little bit of debugging here. Let's go ahead in this particular case. Let's go ahead and put a breakpoint right here. We're going to right click on our P6 modified practice. We're going to change the argument that we had earlier. We're going to change it now to search/price, and we're going to put exactly what was on the command line. So 0.5 to 1.5, and then hit apply and hit OK. And at this point, then when we debug them, we should, unless we have a breakpoint earlier, we should be stopping then right here. All right, good. So let's see exactly what's going on here. This is my first match. I have my command window open, of course, on another screen, so that you can see then what was displayed from our display products, all that seems to work correctly. So now let's go ahead and step through this here. We'll start off. Actually, let me stop this one more time and run this. I want to check real quick to see what my indices are. To begin with, it should technically be equal to null. Let's make sure that's the case. We're going to first start off with looking at the indices itself. There is a variable that exists there, so that's good. Value added is null, so that looks promising. And so we should now see our indices should be equal to whatever value was returned by realloc. That seems fine. And more importantly, then when we step here, we should now get an assignment, whatever that search index is, and we can look at the file to figure out which row should be here. Our search index is returning 0. If we come to our products.csv, for the range we picked of 50 cents to $1.50, yes, we should technically be matching our Coca-Cola, so that looks fine. And if we step again, then let's make sure that we are in fact incrementing our M. That looks good. So M is now 1, and we've incremented our search index, and our search index should now in fact be 2. As a matter of fact, let's go and step again. Let's verify this. By the way, you don't necessarily have to type all these values in the expression evaluator. One of the things that you can do is you could simply look at the variables window as well, but sometimes, as you'll see in just a second, we actually have to drill into a variable, and you'll see what I mean in just a second. But there is, for instance, our indices. You can see the address of it, or the value of it rather, and then the M, and then so on. All right, so continuing on with our debugging, we're going to step again. In this case, our second value, I believe, also matches. And again, we can go back to our products.csv, and sure enough, it does, in fact, match. As a matter of fact, we're going to have a few of them. The first 4 are all going to match, and then the way we've written our if statement, even the 5th one for the Oreos is going to match. 6th one, we probably have too many matches. We could probably narrow this down a little bit to make this a little simpler. I tell you what, I'm actually going to do that real quick. I'm going to go ahead and stop this, and I'm going to modify, just because we're picking up too much stuff to easily debug. I'm going to focus in on a narrower set of values. So in other words, I'm going to try to just pick up the bananas. So I'm going to go from 60 to 70 cents. So let's go ahead and go to properties one more time. And then what I'm going to do is I'm going to change this from 0.5 to 0.6, and then from 1.5 to 0.7. So theoretically, we should only grab the bananas when we run this. Now let's go and debug this again. And the first thing that we want to check is, let's go ahead and check our search index to see, did we actually capture just the bananas? And that's index 5. And remember, that is going to be the 6th element. And sure, all right, so we're catching the bananas. So our search seems to be working fine, but let's actually see now what's going on with our memory allocation. So if I step, and then again, now I can increment our M. We're going to continue to look, and do we have any other values that fall in this range? No, the answer is no here. So at this point, let's go ahead and go down here to our return. Let's go ahead and run all the way through to the return. And what we want to do is we want to check to see the size of M. M found 2. Did I miss another product in here? So we found the bananas. All right, so we seem to have a problem here. I think we've, so there we go. Great. Fantastic. You guys don't understand how happy I am to find bugs, because sometimes I make this look too easy. And that's kind of the purpose of this video. I have no idea how long this one's going to get. In this case right here, I did something really silly, and this was done in an earlier video. I'll actually have to go back and make a comment about it. It was probably when I was moving around code here, but I kept accidentally my M, or my incrementing of my M, in 2 places, and I meant to remove this. And so you'll see here that regardless of whether or not I found a match, I'm basically now incrementing my M, and that's obviously not wrong, not right rather. So the only time I need to increment my M is when I do have a match. And now, if you think about it, if you go back out to our command window, and we'll go to the original command window, that makes perfect sense, because basically I had all of these garbage memory excuse me, all these garbage values for my search index because fundamentally I was looking too far into the memory. In other words, I was looking past the allocated portion of my indices. Now, I'm going to go ahead and fix these here. I am going to go ahead and stop debugging here because I believe I've found the problem. Again, we will see in just a second. I want to check real quick because if I've done it in one place, it's quite possible that I did it in another. I want to see, did I do the same problem over here? No, I didn't. So I have no idea how that bug crept in. But again, this is the nature of programming. Sometimes something that will compile will, in fact, still not run correctly. Or in this case, it'll survive, but it'll cause all sorts of problems. All right, so now let's go back and let's revise this real quick again. 0.6.7. Theoretically, we're only going to capture the bananas. And yes, we have just our bananas. I don't think I've ever been happier to find bananas. And let's go through and let's check a couple more. Let's go from 0.5 to 1.0. In other words, we should capture the bananas and the drinks. And sure enough, there we have our drinks as well as our bananas and our apples. So again, you can sort of see how debugging works. We've got one last thing to check real quick. We did our price. Why don't we go ahead and do our quantity? Let's see if we find any more problems. I'm going to look for a quantity from 0 to 10. And you've come up here, I can see I don't really have too many items that have lower quantities, but I did pick up all the ones that have 10. We can change it to see if we get any additional values by going from 10 to 20. And you can see here that I have all of the items that are 10 to 20, including my 15 here for my Pepsi, which brings us to one last test that we probably should make is what happens if my min and my max are the same. And again, it should work because of the way we wrote our inequalities. So again, this is how troubleshooting works. And again, I could have done some of this behind the scenes. I could have went through and checked each of my individual functions. We'll have some notes to make on some of the other earlier YouTube videos as a result of what we have found, particularly what we saw with the null reference for the sources. But ultimately, it is not a great idea to do all of your integration and testing at once. We got relatively lucky here, but you could see even this was a little bit chaotic. And again, could have simply recorded all of the chaos out. In other words, tested this behind the scenes, but that's not what I want to do. And more importantly, that's not what I do in these videos. So if you see an error in these videos, it's because I made it live. So as always, hopefully this video was useful. If you've got any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.